Volume-based milling is a fast and intuitive way to program parts with prismatic features. You can quickly create operations by simply specifying the volumes to be machined. To program prismatic parts using conventional methods, you typically need to create multiple containment boundaries. These boundaries are necessary to specify the machining volumes. For example, to program this part, you would need to define dozens of containment boundaries. Often, to create just a single boundary, you need to select many geometric elements such as edges, curves, and points. The manual creation of boundaries can be tedious, prone to errors, and time-consuming. When using the conventional programming method for prismatic parts, 75% of the total programming time can be spent on boundary creation. With the volume-based milling in NX, you can program faster using smarter technology that works in the context of the solid model. To demonstrate this new approach, we will program the open pocket on the top side of the part. A key point to note immediately is that NX automatically tracks the status of the uncut material from previous operations. You can see this displayed as a translucent material. We refer to this shape as the in-process workpiece. Instead of needing multiple boundaries to contain an area to be machined, the volume-based milling lets you select floors and walls, and then NX-CAM calculates the proposed machining volume using the current stock model. Before you decide to accept an operation, the system displays the intended cut levels within the identified volume. If satisfied, you can accept and generate the toolpath. Because NX tracks the remaining material after each operation, the toolpath efficiently cuts remaining volumes. Note that if you later change the order of the machining operations, NX updates the in-process workpiece at each stage and recalculates the toolpaths. With the volume-based milling, you can easily program features with drafted walls. This can be a challenging task when using typical conventional 2.5-axis programming methods. In this example, you can select just the floor of the pocket, and NX will automatically recognize the walls of the feature. The system then automatically calculates the machining volume and creates a toolpath. You can validate the toolpath by using the instant preview of the cutting regions. In this case, we use a tapered tool to efficiently machine the pocket with drafted walls. In summary, the volume-based milling provides automation that helps you to program prismatic parts quickly and easily. NX automatically calculates the machining volume from selected floors and walls, thus eliminating the need for multiple containment boundaries. To validate your programming decisions, NX displays the current in-process workpiece and the cutting regions. NX automatically creates smart toolpaths that are safe and efficient by tracking the uncut material. Customers report 8 to 10 times faster programming with volume-based milling.